And welcome back, and it is the 12th of April, further Maths 5 a day, and let's just jump straight to the first one. Right, we've had a couple of these recently, haven't we? So it's a piecewise function, which means it wants you to sketch these equations between the points given. So in other words, I'm going to look at this first one here. That is a graph of minus x, a downward sloping line, between minus 4 and 0. So in other words, minus 4 becomes 4 and 0 becomes 0. So plot these points. Now, in a real exam, be as precise as you can, because they will use tracing paper to check. Now, the one I did recently, I kind of did a bit of a hash job. So I'm actually going to plot all these points. I'm staring at the screen as much as I can, as accurately as I can, just to try and do a better job today. Then I would note that x squared for 0 is 0 and 2 squared is 4. So good, I'm starting from the 0, I'm going through the point 1, 1, I'm going through the point 2, 4, 2, 4 is here. And so again, I'm going to plot a quadratic to show I understand it's a quadratic. So I'm trying to get some curve in here that looks something like this. Then for the final one, again, I have a downward sloping line. Put in 2, so 2 minus 3 times 2 is 2 minus 6, which is 4. And 10 minus 3 times 4 is 10 minus 12, which is minus 2. So again, plot those points. So 2 goes to 4, which is where I start from, and 4 goes to minus 2. Now, in your exam, calculator out, do a much better job than I am doing on an iPad. I'm actually going to do the one in between. So 3, 10 minus 3 times 3 is 10 minus 9, which is 1. So 3 goes against 1, which is here. And again, ruler out, which I'm obviously not doing here, and draw a nice line. And that's going to be my answer. Again, you get a much bigger page in an exam to do it properly. Get your ruler out, you'll do a much better job of doing it neatly. But the point is you show you understand what these curves look like. Either way, question done. Next question. Work out the equation of the line of symmetry of the graph. Well, there's two ways of doing this. Way one, you could complete the square. Nothing wrong with that whatsoever. In fact, actually, it's what I was about to do before I realised that if I take out the 3 and then take out the 2, it's going to involve a whole load of fractions and it's going to be a pain. Way two, just to do something slightly different, is you do know how to do this with differentiation. So if I differentiate, that's going to be 6x plus 8. And I want this to equal 0. And that happens when x equals minus 8 over 6 or x equals minus 4 over 3, which is my turning point, which where the turning point is my line of symmetry. So the answer is x equals minus 4 over 3. Not too bad, that question. Next question. The curve y equals f of x has two stationary points. Okay, this reads quite badly. It's saying there are two stationary points, which it tells me about here, and then it also gives me these points here. Okay, it was confusing me with the points. That said, stationary point 1 is where dy dx is 0, so stationary point 1 is the point 2, 3. In other words, combining these with this. And stationary point 2 is the point 6, 10. And then just for information, it tells me it goes to the point 9. Right, I'm going to try and draw this reasonably well. So let's call this 9. 2, 3 was the third of that, so let's call this 2, 3. Again, I don't want to be super precise, but I'd like to be precise-ish. And 6, 10 is, well, if that's 2, 4, 6, if that's 6, and 10 is about here, so therefore that's going to be 6, 10. Now, two stationary points, add 1 is 3, which means this is a cubic, probably, but let's not get involved in the whole complex roots discussion. So therefore I've got a cubic equation, which I know is either going to do that, or is going to do that. The question is which one? And I mean, I've only really got one solution here, but this is going to help me. In between, I know I'm going up, and the only way of drawing this is to have a curve which comes down here, turns around, that's a bit too sharp, but never mind, turns around here and goes down there. And that is my final answer today. Good questions today. Actually, one thing I missed. Put the point 6 here. There we go. Good set of questions today. I like those questions. Not terribly bad, but equally check you've got them. Let me know how you did. Like, subscribe, and I'll see you tomorrow. Thanks all.